In the next few movies, you use Civil 3D to create a bridge design between the states of New York and Vermont. Civil 3D is sold as a standalone application, but it is also part of a few select Autodesk suites. It is based on the AutoCAD family of products, so if you know AutoCAD, it will look and feel familiar. Before we start, I'd like to make a couple of disclaimer statements. First, this tutorial is not about learning the ins and outs of Civil 3D, so what is featured is a very basic workflow in case you've never used it. The focus is on exporting to 3ds Max Design and seeing what can be done to complete the visualization and animation experience. Second, and perhaps more importantly, I am not a civil engineer. Remember that if and when you spot any design flaws in the bridge concept. If you don't have Civil 3D, you will still be able to use the project files once you get to 3ds Max Design. If you do have Civil 3D though, you will start from a blank page and create a surface based on the GIS data you just downloaded. Since we've established the project is in metric, start the metric version of Civil 3D 2015. In a new blank project, go to the Settings tab. The first thing you need to do is geographically establish the location of your project. Right-click the drawing name to edit the drawing settings. Apart from the drawing units in this dialog, you need to set up a geolocated coordinate system. You can select a country or a state, in this case USA, New York, and choose an available coordinate system for it. There may be many to choose from. In this case, choose the NAD 83 East Zone Meters or NY83E. Click OK to accept the changes. Next, go to the Prospector tab and right-click on Surfaces. Choose Create Surface to add a surface definition. Give it a name, such as Crown Point EG, EG for existing ground, and click OK. Expand Surfaces Crown Point EG definition. Although you have officially created a surface, it is currently only a placeholder, as you haven't yet specified what data it is based on. Right-click the DEM files entry and choose Add. Under DEM file name, point to the DEM file you created in the last movie. Make sure the DEM file is in the C3D to 3ds Max on the C drive, as that's where it will be referenced from this point forward. If you haven't created your own DEM file, as shown in the last movie, you can use the one provided to you and named crownpoint.dem. That's the file that's referenced in all DWG files you downloaded for this tutorial. You still need to enter a coordinate system for the DEM data so that the surface is located in the right place. Fortunately, that data is provided to you by the DEM file itself. So instead of entering the coordinate system based on country or state, you can enter it based on UTM and zone values as shown in the DEM file. That would be UTM NAD 27 datum, zone 18 metric. Once you have accepted these values, Civil 3D will compute and create the 3D surface accordingly. This can take a few moments based on the speed of your system. You may be prompted to use Level of Detail Display Mode. Select it to see what it does. The surface is not yet displayed, but that's because it is far from the current point of view. Type ZE for Zoom Extents and press Enter. The surface appears, and because Level of Detail Display Mode is active, it appears with very little detail from a distance. Only a few curves show, but the surface gets more dense as you zoom in. Another way of confirming this mode is active is by the little icon displayed in the top left corner of the viewport. You can disable this mode under View, Views, and clicking the Level of Detail button. Bypass the warnings by keeping the current display mode active, and you can see the detailed surface now in all its glory. Civil 3D has a nice integration with Bing Maps, so you can see your surface overlaid on actual satellite images. For that, you need to be logged into Autodesk 360, so if you haven't done so already, go ahead and create an account. Once that is done, and in order to see the aerial map in the viewport, you need to enable that option in the Geolocation tab. The created surface is quite detailed and somewhat too big for your needs. You only need a small part around the water crossing area. In fact, you need to define the same area you used earlier to create your ground texture map. Instead of fiddling with the original surface, you'll make a copy and trim that copy to the area of interest. That will also enable you to bring down the level of detail on the copy, while the original surface retains its resolution. Start by hiding the original surface. Right-click the Crown Point EG entry and choose Surface Properties. In the Surface Style drop-down, choose No Display and then click OK. The surface disappears from the viewport, but you can still manipulate it in the prospector window. Next, you draw a rectangle over the area of interest using the Rectangle or Rec tool to that effect. It is important that the area you select here is the same one you defined when you created the aerial image earlier. This ensures that the ground texture image you created maps itself properly to the extents of the created surface. First, draw a couple of lines to define 2 corners for your rectangle. Start the first line at this intersection point. This is the same point you use as a top left corner for your ground image. Zoom back and create another temporary line, starting at the white speck among the trees, the same one you also used earlier. Now create a rectangle by snapping to those 2 reference points. If your object snaps are not active, use the F3 toggle. Delete the 2 lines when done. The area inside the rectangle is the area of interest. Both the surface copy and the Civil 3D aerial maps will be restricted inside that rectangle. It is also the same size as the texture image you created earlier. This ensures mapping coordinates work well when the map is later projected onto the terrain in 3ds Max. To crop the Civil 3D background map is very easy. Simply use the Capture Area tool and snap to your rectangle. It doesn't look like much happened, but if you were to turn off the aerial map now, you would see that it's still active inside the rectangle. This is actually a tool that helps for printing maps in Civil 3D, but we're using it here for reference only. It is lighter to use than a full-blown aerial map background. Click on the copyright label to select the capture area, and then zoom in on it. You'll notice the map resolution is less impressive than before. You can help it by switching the quality from optimal to fine, or even to very fine. You still need to create a copy of the original surface and crop it to the area of interest. Create a new surface as before, and name it CVCP-EG, Civil View Crown Point Existing Ground. This is the surface you will need to crop and eventually export to 3ds Max Design. It's empty at this time, as it has no data yet. Expand its hierarchy in the prospector window. Right-click on Edits and choose Paste Surface. A dialog appears with existing surfaces that you can paste. Obviously, there's only one, the surface you created from the DEM file. Select it and click OK. After a few moments, a copy of the original surface is displayed. To trim it, right-click the Boundaries entry and choose Add. Give the boundary a name, such as Crop or Limit, and click OK. Click the rectangular area you drew earlier. After computation, the resulting surface is now contained within the area of interest. It also has the same boundaries as the texture image you created earlier. As mentioned, the surface is still quite detailed. You may consider simplifying it prior to exporting it to 3ds Max. You can simplify the copy so that the original surface remains untouched. Right-click Edits again under the CVCPEG surface and choose Simplify Surface. Accept the defaults in the first two panels, but consider the third. A slider lets you adjust the level of simplification. 50% means the new resulting surface will have half the definition of the original one. Hitting Apply brings the points number down from 300K to 150K. Also, bear in mind that hitting Apply means you've already simplified the surface. Click Cancel to exit the dialog. If you click Finish, you'd be simplifying the surface one more time down to 75K points. Actually, it's not a bad thing in this particular case. Even at 75,000 points, the surface would still be dense enough for good detail in 3ds Max. The Edits list shows you the processes that have been applied. You have created the needed surfaces and adjusted the area of interest to match the ground texture image you saved earlier. Save your file. You are now ready to create the components that will help you build your bridge. This is what you learn to do in the next movie.